Hi everyone, welcome back to my YouTube channel. This is part 6 of our 30 most important system design concept series, which every software developer should know. So, before this video, we have already made 5 parts of this series, in which we have discussed on top 25 important system design concepts. And in this video, we will be looking into next 5, completing our all 30 important system design concepts. In this video, we will be looking into topics like microservices, message queues, rate limiting, and API gateway and idempotency. So let's begin. Our first topic here is microservices. So before we know microservice, we should know something which is monolithic. Like there is a architecture, microservice is a architecture, and before this we used to make use of monolithic architecture. But before understanding microservices, we should know what monolithic means. So traditionally all the applications were built using the monolithic architecture. So what monolithic architecture does, in monolithic architecture all the features are inside one large code base. So there was a problem with that. So let us consider we have an application. I have an application where we sell some courses. So in my company I would have employees, I would have courses, I would have customer or the students. So all of these datas were together in one large code base. So if I want to do some changes in my course module or course file, and if there is any kind of error, it and we deploy it with along with the error, the code changes, we deploy it, then what happens, the whole code base, the whole application will get hampered, only because there was some change in course. There was no relation with employee, there was no relation of that file with customer module, but the entire application will be hampered. So that is what is called as monolithic architecture. And this setup works fine for the small application, but for the larger applications, monolithic, this becomes hard to manage and scale and deploy. So these were the problem with monolithic architecture. The solution is to break your application into smaller independent services, which are called as microservices that work together. So our all the code base, our entire code base, they are split into multiple pieces, multiple modules, and they will work together, but they are independent of each other. Independent of each other, by that I mean that deployment also is independent. Like any change in employee module, we can deploy this whole module separately, but we need not deploy other things because every module is independent. So each microservice, they handle their single responsibility, and they have their own DB, and they have their own logic, so that we can scale them independently without disrupting into other module. Communication with the other microservices. So there are some way, there should be some way how we should be able to communicate between microservices. For example, if I am adding some video in my course and I want to notify it to my clients or to my customer or students, then there should be some way how we communicate between the APIs. So how do we do that? Either by API call, or we make use of message queues. So message queue is the next topic which we will be seeing. Synchronous communication, for example, waiting for the immediate responses doesn't scale well. Message queue enables service to communicate asynchronously, allowing requests to be processed without blocking the other operation. So let us consider an example that in my application, if user does any kind of password reset or any account sign up issues, then I have to send them an email. And there is also a marketing campaign going on, that I have to send you a newsletter. For that also I have to communicate with the different microservices, and I have to send you an email. Okay, this is the example which we will be discussing. So how it works is, there will be producer which places the message in the queue that what it is supposed to do. Like there is some logic already written, and after calculating those logics and all, we have to trigger the next microservice, so that it is going to trigger an email for that particular user. So producer, it places the message in the queue, and queue temporarily hosts the message, and consumer will retrieve the message and process it. Okay, and it is asynchronous, so it is not going to block the other operation. And using messaging queues, we can decouple the services and improve the scalability, and we can also prevent the overload on internal services within our team, within our system. So this is about the message queues. Our Next topic is rate limiting. So let us consider, if our application has grown and there would be multiple users trying to access our application, that is fine. But what if there are some bots or there are some hackers making thousands of requests per second to our website? So how do we prevent the overload of the requests to our public API or the services which we have deployed for our application? Without restriction, this the bot who are trying to send multiple thousands of requests to our server, without restriction, this is going to crash our server, and it will consume all the available resources, and it will degrade the performance for the genuine and legitimate users who want to access our application. So rate limiting, this restricts the number of requests a client can send within a specific time frame. So every user or the IP address, that is the device client, it is assigned with a requested quota, that this will be the maximum number of time you can send the request in this particular time duration. For example, there can be 100 requests per minute. So if the user exceeds this limit, then server is going to block the additional request temporarily, and it is going to return us an error that too many requests have occurred and currently we cannot give you the response. So there are various rate limiting algorithms. Some of popular ones are fixed window, that is, for example, 100 requests per minute, that is example of fixed window. Then we also have sliding window algorithm and token bucket. So this is about rate limiting. Our next topic is on API gateway. Our fourth concept is API gateway. So in API gateway, like previously we have discussed on rate limiting, right? So we need not implement our own rate limiting system. This can be handled by something called as API gateway. So an API gateway, it is a centralized service that handles authentication, it handles rate limiting, it handles logging, monitoring, request routing, and much more. So API gateway, it handles so many things for our backend application. An API gateway, imagine like we have a microservice based application with multiple servers. So here we have multiple microservices, okay, where we have multiple APIs. So instead of exposing each service directly to the client, API gateway acts like a single entry point for all the client requests. So it is going to collect all the client request, and it is going to route the request to the appropriate microservice, and response is sent back through the gateway only to the client. So it is going to get all the request, and based upon routing, it is going to send that request to the specified or that particular microservices, and we get the response also via gateway towards the client. And API gateway, it simplifies the API management and improves the scalability and security. Our next topic is about idempotency. So let's consider an example that we have visited a application or distributed system where, because of some network failure or some service retry or something like that, user accidentally refreshes the payment page when they were trying to pay the amount. They have done some refresh, or there was some network issue because of which refresh happened. Now system might have, backend might have received two payment requests instead of one, and if there is reduction of the amount two times from the user, such mistake cannot be afforded by any application. No user is going to use your application if such big mistake happens. So idempotency is a concept which ensures that repeated requests produce the same result if the request was made only once. So request was made only once, but because of some issues, it got duplicated, and now we have to make sure that if there is repeated request, they should produce the same result. There should be only one response to it. So how it works is, each request is assigned some unique ID, okay. So before processing, system checks if system has already handled it using that unique ID. If it has already handled, it ignores the duplicate request, and if it has not handled, it is going to process the request normally. So you can see code accidentally runs three times. In non idempotent runs payout $100, so three times our amount will be deducted, whereas in idempotent code only first time our amount is deducted, and other two times it is skipped. So these are very important 30 important system design concepts we have